Okay, let's go to the second demo, which is actually an impact analysis use case based on Mars rover data, and we have this nice astronaut, and he wanna wanna handle the Mars rover on the Mars surface, and as the Mars surface is very wavy, it's currently designed for a gradient of 15 degrees. So that's all the Mars rover can currently cope with. And well, now he thinks, well, is the 15 degree, is that enough of a gradient the Mars rover can do? And could it potentially be could it potentially do more? So the first task is he want to look at the data that's currently available in OpenCLM, and he would like to check with the impact. So that's the research project with the reference model generated there, whether this is possible. And so therefore, let's go into OpenCLM and look at that then. Oops. So we have it here. Okay, and here this guy has the Mars rover project here, and he opens it up, and what you see here, that's exactly the structure, the product structure. We call it within the project, we call it parameter space, which is a standardized way on how to look at the project. You see there are certain structure behind that, and like for example requirements, and here is the product components, software components, hardware components. So there's a standardized way on how you deal with all of that stuff. And now, of course, the question is how do we deal with that? And then this guy would look at the model element, yeah, and then all by a sudden he sees, okay, there is the Mars environment surface model. So that somehow sounds like this is the right place to start. Okay, and then he looks at it and he sees, okay, the Mars environment surface that has some relation to the gradient, which is of course quite obvious. So there is a trace link between the Mars environment and this gradient, yeah. And therefore, the basic idea is, well, okay, let's start an impact analysis on that gradient. And so what you see, the gradient then, on the other hand, has some dependencies. If we start here, we see that there is the locomotion over gradient requirement. If we would look at that, then we see, okay, the rover must be able to move independently on gradient, and there is the property value of 15 degrees. So that means that's exactly that requirement that we already know about and that we have there. And the other one then is the tilt sensor. So our Mars rover has a tilt sensor. So let's have a look at that. And we see, okay, that's the tilt sensor. That is modeled in sim database on one hand, and there is of course some dependency. So there is some software associated to that as well. And of course we can have a look at the software. So that then goes to a GitLab repository, and here we can see how the source code for the tilt sensor looks like. Okay, tilt sensor. Okay, so that's probably not all we want to look at. So probably we somehow need to dig deeper into that, and so therefore we want to look for all the configuration items, and those are the filters Anna was talking about, and we somehow need to get indirect links. So we at least go to the next level, which is level 2. And looking for that. And if you look at that, then all by a sudden, okay, there are some new elements popping up. And interesting enough, the gradient and has some dependency on the torque. And as you see, that's an indirect link. Yeah. So, and torque, somehow that could be something that's somehow related to the gradient, and could help us to evaluate whether we can whether we can do more than 15 degrees. Okay, so therefore we look at the torque, and we see, okay, the torque then, that's related to the base wheel assembly. That's one thing, and therefore probably let's look into that, what's in there. Yeah? And so we do that, base wheel assembly. Okay, and then all by a sudden we realize, okay, oh, with the drive motor, that could be the thing that is of interest for us. So we look at that one, and then we see, okay, the drive motor, that again is in sim database, and then probably let's have a look at what's in there. Sim database takes a little while, but here we go, and we see, okay, now we are in sim database. That's our drive motor, and we can have a look at the data sheet. Unfortunately, this is German, but doesn't matter. And all by a sudden we see, okay, the drive motor actually can do a maximum torque of 23 kilograms centimeters. And that's of course something that could help us. And so our astronaut, he does some calculation. Oops, sorry. He does some calculation, and based on those 23 centimeter, he calculates that he can really make a gradient of 30 degree. And what he want to do as a next step, of course, then he want to document this in OpenCLM. So based on the information within OpenCLM, he has found out, and some additional calculation, that he can do much more than these 15 degrees. Good. So let's see on how that then is documented within OpenCLM. Good. Let's switch back to the screen. Okay, that was this. Go back into OpenCLM. Okay, and then so there is the maximum gradient, CI, and that is where the 15 degrees is in. Okay, we now know it's not just the 15 degree. We can do much more. So we create a version of this. And we are looking for the 30 degree artifact, which I've already added. Sorry, 30 degree. And here we go. So we take this artifact, selected artifact, and then create the version. So you see we have the maximum gradient, 30 degrees. The same now, of course, we're doing with the locomotion over gradient requirement. We go into that and we create a version of this one. Of course, we take over the text. Sorry, we take over the text of this one. And in addition to that, of course, we are looking again for the 30 degree artifact. And we are adding this, select the artifact, and then we create a version of this one, and have this one now as a new version. So we now have documented within OpenCLM that based on the current data we have, we can do the 30 degree, and we have done it in a traceable way. And even you can see from the version history and all these type of things that those things work together. Good. So that's the second piece of the demonstration.